Hi everyone, so let's solve this problem. Well, this problem actually is talking about if we have a certain amount of the HCl react with a certain amount of the sodium hydroxide. And those reaction is the exothermic reaction. It will generate heat, and the heat warm up the solution um, to make the temperature raise from 22 Celsius to 30.5 Celsius. And the question is asked for what is the energy capacity in joules per mole for the formation of the water. Well, for this question, it looks like it's a complicated, but actually we can divide this question into several pieces. First piece is we need to figure out the how much heat is released from this reaction. And this reaction we talk about is a sodium hydroxide react with HCl. And the second part is we will figure out how many mole of water is generated from this reaction. Okay, the third part is, okay, once we know the heat and also the mole of the water, the energy capacity will be equal to the heat divided by the mole. Because you see, the unit here is a joule per mole. It's just the heat divided by the mole of water. Okay, so let's do it step by step. Okay, so first we need to figure out how much heat it generates. Okay, for the how much heat of the generate, we can use the equation. The Q of this reaction, the reaction which is sodium hydroxide plus the HCl, is equal to the heat. This reaction generates heat. So the Q release is the Q gain. What's the gain? The heat of the gain is the solution. The solution gain the heat. So the solution temperature is raised up. So that is equal to the negative sign of the specific heat of the solution time the specific heat, the mass of the solution, and the time the final temperature of the solution minus the initial temperature of the solution. Okay, so we can, before we doing this equation, we can list the parameters on the side. So we do have the specific heat of the solution. It already shows in the question, which is 3.89 joule per gram per Celsius. And the mass of the solution, we need to do the calculation a little bit. Okay, so let's think about the mixture. The final mixture, the final solution is made by the sodium hydroxide solution and the water and the HCl solution. Okay, and also the question tells us the density of the resulting mixture is 1.05 gram per milliliter. Okay, which means the mixture, the mass of the mixture or the mass of the solution can be calculated by the density times the volume, and the volume is the sum of the volume of the HCl times the plus the volume of the sodium hydroxide. So the mass of the solution or the mixture is the density times the volume. And the density is 1.050 gram per milliliter, and time the volume of the HCl plus another 100, which is the volume of the sodium hydroxide. So we put this into the calculator. It's 1.050 times 200, which is 210 gram. 10 gram, 0.0 gram. Okay, and the final temperature, we know. The final temperature is 30.5 gram. Sorry, 30.5 Celsius. And the initial temperature is 22.0 Celsius. Okay, and then we put everything into the equation, which is negative 3.89 joule per gram per Celsius time the mass, which is 210.0 gram, and the time the final temperature 30.5 Celsius minus 22.0 Celsius. Okay, and put everything to the calculator and then figure out. Let's figure out 3.89 negative time 210 time parenthesis 30.5 minus 22.0 Celsius parenthesis. So this one is a negative 6943.65, negative 6943.65 joule. Okay, so this is the energy, how much heat is released. Okay, let's mark this is number one. First part we need to solve for this question. I'm not going to round up this number because this is just the middle of this question. Okay, then let's solve the second part. Okay, let's solve the second part. The second part is we need to figure out the mole of the water it generates from this question. Okay, so let's set up this equation first. This is a sodium hydroxide react with the HCl solution. This is acid-base reaction. It generates the water liquid plus the sodium chloride, which is also aqueous phase. Okay, so before we're doing so, we need to we know the mole of the sodium hydroxide and the HCl, and we need to figure out what is the mole of the water. Okay, so let's list what is the mole of the sodium hydroxide and what is the mole of the HCl. So the mole of the sodium hydroxide can be calculated by the molarity of the sodium hydroxide, which is 2.0 mole per liter. And this is what the question given. And the time 100 times the volume, which is 100 milliliter. And this question, this is liter, so this is a milliliter. So we need to convert the milliliter to liter, which is we time the milliliter put in the bottom and the liter on the top. 1 liter is equal to 1000 milliliter. So the mole of the sodium hydroxide is 2.0 times 100 divided by 1000. So 0.2 mole. This is a 0.2 mole of the sodium hydroxide. And the mole of the HCl actually is the same thing. It's also molarity of the HCl times the volume of the HCl. It is the 2.0 mole per liter times 100 milliliter and time 1 liter over 1000 milliliter. And we got 0.2 mole of the sodium HCl. So the mole of the sodium hydroxide and the mole of the HCl, those are the same. So we have a 0.2 mole of the sodium hydroxide. We have a 0.2 mole of the HCl. And you can see, okay, 1 mole of the sodium hydroxide react with 1 mole of the HCl to generate 1 mole of the water. So this is a 1 to 1 to 1 ratio. Then we have a 0.2 mole of the sodium hydroxide and a 0.2 mole of the HCl. Then we can generate a 0.2 mole of the HCl, H2O, which is water, right? So we can directly just get the mole of the water is equal to 0.2 mole, right? Okay, and this is the part 2. Okay, then the part 3 we got. Part 3 is we're using the heat of the reaction over the mole of the water, right? So the heat of the reaction is we already got. The heat of the reaction is negative 6943.65. 6943.65. Negative 6943.65 joule divided by mole of the water, which is 0.2 mole. Okay, then you use the calculator to do the calculation, which is 6943.65 negative divided by 0.2, which is negative 34718. Negative 34718. 0.25 joule per mole, right? Okay, and finally we got this number. Then let's see what's the sig fig. Where did I? Okay, then let's see what's the sig fig. We have 2 sig fig and 2, 4, 3, 3. And here this is 100, 100. So we only have 1 sig fig in the end, right? 100, that's just a 1 sig fig. The trailing zero doesn't count. So we only have 1 sig fig in the end. So if it's only 1 sig fig, we keep this as the 1 sig fig. For the final, it's going to be negative 330K joule per mole. You can write like a negative 3 times 10 to the 4 joule per mole. Okay, yeah. So this is the final result. I hope you got it. Okay, so I'm glad you watched the video. Okay, bye.